Okay, so we are going to now pounce into grade 12. I think I'm just gonna do that up until the wee hours of the morning, like 1:30. So maybe we can share this live calculus. Okay, I do understand that with calculus, there's a variety of things that are done there in calculus paper 1. So in my YouTube channel, what I have been doing is I've actually done some previous lessons with the grade 12s that have to do with paper 1 related topics. So I'd already posted up during a few weeks back. We did paper 1 related topics, and by that I mean we did what did we do, Ganen? We did question 1 type questions. We did sequence and series. We did functions. And now I want to look at calculus so that we can cover a little bit of calculus in this session. And then we will see all the others at another time. But I think we can start here with calculus, because it is one aspect of the maths that needs some sort of like attention. I hope those who are joining in can let me know as to like how the network is. Let me know how the network is, so that if the network is unstable and there's funny things happening, the connection is not so great, I can attend to that ASAP. Okay, so for the next few minutes I'll be doing calculus. So let's look at the first question here. It says, determine f prime x from first principles if f of x is equal to 7 first principles. Alright, and what they've done here is they've actually set us up on the formula for first principles. Okay, yeah, but of course, so that this is f prime x is equal to the first principles formula. So f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we have been given f of x and we have to determine f prime x from first principles. So this should be really nice and straightforward. So what we do is we first make sure that we know what f of x is, and we can see it's 7x squared plus 1. Why? Because we are going to substitute the essence of f of x here in the place of f of x. Now all we need now is f of x plus h. So what I like doing is I like actually finding the expression of that on the side, then substituting everything after I'm done. So I'm going to find what f of x plus h is, which means in the place of x, where 7x squared is, where x is, I'm going to substitute x plus h. So I'm going to write down 7. Then where x is, I'm going to substitute x plus h. But then remember, there's a squared, so I write the squared and then the minus 1 will follow. Okay, so that's f of x plus h. Then what I'm going to do after that, grade 12s, is I'm actually going to then expand this so that it actually gives me what I need. So hopefully the expanding for all of us is not a problem, because x plus h, the whole thing squared, is simply we square the first term, we square the last term, and then we multiply the 2, and then we multiply the 2, and then we multiply by 2 as well. So x times h is xh, and then we multiply it by 2, we get positive 2xh. That's how we deal with a sum or a binomial squared. We square the first term, we square the last term, we get the last term, and then to get the middle term, we multiply the 2 terms, and then we multiply them by 2. So we get 2xh in this situation. So it's x squared plus 2xh plus h squared, bracket and then the minus 1. Then now we have to take the 7 and distribute it to the 3 terms. So that gives us 7x squared plus 14xh plus 7h squared minus the 1. So now we have f of x plus h. We have f of x, which we can now substitute in the place of f of x. We have f of x plus h, which we have found by substituting x plus h in the place of x in brackets where x is, and then expanding it out. This is very important, being able to expand this out, multiply in the 7 for the 3 terms, and then subtract if there's any like terms, making sure that those like terms are sorted out. But as you can see, 1, 2, 3, 4 of these terms are all unlike terms. There's nothing you can add here. Substituted, and f of x plus h can be substituted into the first principles formula. So we just simply say the limit as h approaches 0, what is f of x plus h? Remember, it is that 7x squared plus 14xh plus 7h squared minus, now in brackets please, we write that 7x squared minus 1. Okay, and everything is over who? Over h. All right, then the limit as h approaches 0, then we can look into that numerator. We have 7x squared plus 14xh plus 7h squared minus 1. We forgot the minus 1 there. Remember the minus 1? We forgot there. It's very important, guys, that when you take down this f of x plus h, make sure that you do write each term distributed into the binomial of 7x squared minus 1. Remember, when you substitute this f of x, which is 7x squared minus 1, you put brackets around the 7x squared, and the negative sign you distribute. That will give you negative 7x squared plus 1, because the negative times the negative gives you a positive. Now, I'm sure you are in the position of adding the like terms. Now 7x squared minus the 7x squared gives you 0. Minus 1 plus 1 gives you 0. So that means we are left with 14xh plus 7h squared. Alright, that is still there, that is still there, that is gone, that is gone. We are left with 14xh plus 7h squared over who? Over h. Not forgetting the lim as h approaches 0, that equal sign, because the f prime x is there. Now we can take out the highest, we can take out a common factor of h. We take out the common factor of h deliberately here. That's very important. The h alone, so that it cancels with the h in the denominator. That cancels. All right, then after that cancels, we are left with 14x plus 7h. Then we say the limit as h approaches 0. Now we can actually substitute that 0 in the place of h. So we have 14x plus 7 times 0. What does that give us? It gives us 14x. That is f prime x. So f prime x is equal to 14x, and that's it. Okay, now we can quickly come and check if this answer is correct. Okay, and it's very easy to check if this answer is correct. All we simply do is we use the power rule and we derive this. Okay, obviously that would mean 7 times 2, which is 14. X 2 minus 1, so that would give us 14x, and then the derivative of a constant is 0. So this 14x really makes sense. This answer is really correct. So it means that our simplification, our substitution, and everything that we did here is 100% correct. We are 100% on point. So hopefully, guys, you can now see how easy it is to actually derive using first principles. And I just want to remind you that when we derive using first principles, we need to know what the expression of the f of x function is, it's 7x squared minus 1. We need to then get the f of x plus h by utilizing our substitution in the place of x plus h, the whole thing squared. We multiply out, guys. We multiply out, please. We square the first term, square the last term for the first and the last term of the trinomial. And then, of course, we know that if we multiply x times h and then multiply it by 2, we get positive 2x plus 2xh. We then distribute the 7x squared, 7 times 2xh is 14xh. 7 times h squared is 7h squared, and then the minus 1 is a constant term outside the bracket. Then after that, we take the f of x, go and substitute it in the place of f of x in brackets, please, because there's a minus sign, and then we substitute f of x plus h as our first term. We then take the negative sign outside that bracket, we distribute it, we get negative 7x squared and positive 1. Then we add the like terms, we get 14xh plus 7h squared over h. We take out the common factor h, deliberately just the common factor h, even though we know there are other factors, but we take out the common factor h so that it can cancel the denominator. And then after that, we get the limit as h approaches 0. We can then substitute in the place of h, because the h in the denominator is gone. Substitute in the place of h 0, so that gives us 14x plus 7 times 0. This limit as h approaches 0 falls away when we substitute, so it must not be there anymore. And then we write our answer, which is 14x. What is that? It is the f prime of x that we are supposed to determine using first principles. Tone 7, why this late? Because grade 12s are always late. You know, they are always late. Let's go and do 1.1.2. The question says, hence or otherwise determine the gradient of the tangent to f of x is equal to 7x squared minus 1. Tone 7, this is the time when you guys show how concert at this time of the night. If you were expected to attend a Tyler concert at this time of the night, you would never say why this late. You would happily go to that. I guess it just means it depends on your personal priority. Point x is equal to negative 1. What do we need to do? Determine the what? The gradient of what? The tangent to what? This function. At which point? At x is equal to negative 1. Now, you guys know that if you want the gradient of something, f prime at that point, at that value of x point, will give us the gradient. So this is important. The derivative of a certain function at a specific point of x is equal to the gradient, all right, at that point. So we already determined the gradient, the derivative, of f prime x. So that means we have 14x, which is equal to m. Now we were told at which specific point that we're supposed to actually substitute. That is 14 into negative 1 is equal to m. So what's 14 times negative 1? It's negative 14. So therefore the gradient is equal to negative 14. The gradient of the tangent to this function at the point x is equal to negative 1 is actually negative 14. That is the gradient. So what we would have to do, you see they're saying hence. Hence means use something that you have done in the previous question. So we got the derivative of 7x squared minus 1 using first principles. It is 14x, right? So since we have the derivative, we are hensing the question. We are taking that first derivative, which we got already, substituting the point x is equal to negative 1, getting the gradient of the tangent at that specific point, which is x is equal to negative 1. So m is equal to negative 14. Any questions that you guys have about how to determine the gradient of the tangent to a specific point for a specific function? Are we flowing together? Do we understand the fact that I hensed this question? I could otherwise this question if I wanted to, and that is just finding the derivative using the power rule. I would have still gotten 14x, of course, and then I would have substituted the value of x, which is -1 at that point, so that I can get the value of the gradient. Okay, well, that's great. Then if we are all clear, all systems go, then great. Let's move on to 1.2. Okay, 1.2 says determine f prime x for each of the following. So all of these three require us to do what? To find the derivative using the power rule. But guys, please, let's driving finding the derivative. If you have separate terms, I repeat, if you have separate terms in your expression or in your function. So let's look at 1.2.1. Do we have separate terms for our expression? Do we have separate terms? Thank you, Maximi, for the TikToks. Really appreciate them. Do we have separate terms? Yes, we have 1, 2, 3 terms. So they are separate, which means we can use the power rule immediately. Power rule immediately. Here, do we have separate terms? Yes, we do. Are all the terms 1 and in the numerator? Because we need to make sure that all of these terms are in the numerator. There's nothing in the denominator for each respective term. So you can see this one, or they need to be in the numerator and they need to be in exponential form. So there are 3 conditions to using the power rule. 1, separate terms. Let's spell out our condition. Separate terms. 2, all terms. 3, in exponential form. If this is the case, guys, if we have separate terms in the expression, all terms are in the numerator, and they are all in exponential form, then power rule can be used. Power rule can be used. If these things are not in place, then power rule can't be used. Okay, so we need to have separate terms. All terms must be in the numerator, and in the numerator they must be in exponential form. So look at this, guys, look at this. F of x is equal to fx 5x cubed minus 7x minus 3. This term is in the numerator, the variable is in exponential form 100%. 7x in the numerator, variable 100%. Is third term in the numerator. Okay, and obviously what's nice is that even though it's not in exponential form, it's a constant term, and in actual fact there's nothing that basically needs to be done further for simplification. We can derive, use the power rule immediately. 1.2.2, square root of x, not in exponential form. We can convert it into exponential form, which is great because we can change the definitions and the rules that can help us to do that. -1 is a constant term, so that's fine. Here, this is one term so far, but the thing is, with this one term, we need to apply some simplification to the numerator and the denominator for factorization, so that simplification can happen, so that we can get to a place where we have separate terms. So currently, we need to actually take care and do things to this particular expression so that we can get separate terms. So what's nice is that, guys, we know what we need to do. So here we are ready. So what do? We say f prime x, because derivation can happen. Then what do? We know that when we apply the power rule, we say 5, we bring down the exponent 3, we multiply, we retain the variable x, we retain the exponent 3, but then we subtract 1 from the exponent 3. So I'm just showing you the steps so that you can see it. Otherwise, in the next question, I won't be doing that. I'm just showing you guys that this is what we do. We're taking the exponent, we're multiplying it with the coefficient that's currently there. We retain the variable x, then we subtract from the current exponent -1. We do the same thing for each thing. 7, the x variable has an exponent 1, so we times by 1, x 1 minus 1. The current exponent for x is 1, so we subtract 1. Minus, here, the derivative of a constant we are told is 0. So what's the final verdict? 5 times 3 is 15. 3 minus 1 in the exponent is squared. Minus 7 times 1 is negative 7. 1 minus 1 is 0. And then minus 0. Obviously 0 means nothing. Final answer, we can write 15x squared minus, now the 7. The x to the power 0 is 1. X to the power 0 is 1, so 7 times 1 gives us 1, which means this is our answer. F prime x is equal to 15x squared minus 7. So that's how we find the derivative for that one. Look at this one. Firstly, how many terms? 1, 2, 3. So they are separate. So tick, we are separate. 2, all terms in the numerator currently, and then in exponential form. So this term is in the numerator, but it's not in exponential form, but we can rewrite it so that it is in exponential form. So we say we still keep f of x because we are not deriving yet. We are still wanting to still get everything prepared first. No, it's like someone who's cooking. Someone who's cooking doesn't just throw things into the pan. You know, you don't take your onion as it is. You know, you get it from the shop and you take it as it is and you throw it into the pan or the stove. You have to first cut it up and prepare. So it's the same way. We need to first separate terms, make sure all terms are in the numerator, and make sure that the terms are written in exponential form where the variables are concerned. Oh, Mrs. Him, you want to make me cry. Seriously. Oh my soul. Thank you so much for the confetti. Like, Mrs. Him, I want to take a moment and say thank you so much. Like, I don't know, like you, yeah, hey, yeah, when you just want to make me cry on this live, like, seriously. But yeah, thank you from the bottom of my heart. Thank you so much for the confetti. Really appreciate it. I appreciate the gifts all the time. Thank you so much. So we need to separate the terms, make sure all terms are in the numerator, and make sure that our variables are in exponential form. So let's go. The square root of x, we can rewrite it to become what? X to the power 1 over 2. I just want to take this aside and show you something. The square root, guys, all right? This x has an exponent that you can't see. It's 1, all right? And the square root has a hidden root here, okay? Square root means there's a 2 there, but we don't usually show it, okay? So when you remove the square root and you want to write this square root into exponential form, what we simply do is we show that 1 that was not seen, and it becomes our numerator value for our exponent, our rational fraction exponent. Then when we remove the square root, it becomes x to the power 1 over 2. Okay? All right, I hope that makes sense. So this x to the power 1, the square root of x to the power 1, becomes x to the power a half. All right, I just want to say that if, let's say, it was x to the power 2, and let's say it was a cube root, all right, the square root, the x squared, say x to the power, this 2 becomes a 2 in the numerator for your fraction, and this 3 is in the denominator. So it's x to the power 2 over 3. So I hope you guys see that whenever you have a root form, you can, in actual fact, in essence, root of x to the power m, this can be written as x to the power m over n. Very, very important. When you remove the nth root, the n goes to the denominator. So I'm sure you can see in the denominator, but him in the numerator, root of x is x to the power laws that say what? 1 over x can be written as what? If you have a variable in the denominator and you wish to write it in exponent, the exponent that it has currently, which is 1, changes in the numerator and becomes x to the power negative 1. Okay, that's when we have division of two things and the denominator is a base, right? And it has a particular exponent. When we change this from this fraction form to the exponential form, the variable in the denominator changes position from the denominator to the numerator. Then the exponent that was there changes sign. Okay, guys, it's like if there's 1 over x squared, this would be actually equal to x to the power negative 2. Okay, this 1 that was there in the numerator is still there in the numerator. It is the coefficient of the variable that now has a negative exponent. This 1 that was there is there already as well. It is the coefficient of the variable that now has a negative exponent. Just want to do one more. If you had 2 over x squared like this, okay, the x squared joins the 2 and the x has a negative exponent, guys, and this is very important. Okay, so this is how we are able to make sure that we get our terms in exponential form. So look at 6 over x. What do we have? What do we write it as? 6x to the power what? Negative 1. Do you see? I hope we are hammering together. Okay, then lastly, minus 1. Obviously, minus 1 is minus 1. It's a constant term. So now, what did we ensure? Terms are separate? Check. All terms in the numerator? 1, 2, 3 in the numerator? Check. In exponential form, if the variables were not exponential form, check. Exponential form, check. Constant term is a constant term. So now we are ready to what? Apply the power rule. Power rule can be used. We are ready to derive. So since it's f of x, then of course we write f prime x, guys. It's as simple as that. We are ready to derive. So of course when we're deriving, it means that we say half the x. Obviously the half comes down to the coefficient, becomes half, the variable retains, then we subtract minus 1 from half. Okay, minus 6 times negative 1, x to the power negative 1 minus 1, and then obviously the derivative of a constant negative 1 will be equal to 0. So when we finish off, we get half. Now the x to the power negative half minus 1, that gives us what? X to the power negative half. Negative times a negative, positive 6x to the power negative 2, and obviously that 0 is still 0, so we don't even have to write it. Final answer, final answer, final answer equal to, I just want to use the 2 spaces, 1 over 2. Now we can write x to the power positive half in the denominator if you want. 1 over 2 x to the power positive half. Remember, this x to the power negative half is in the numerator, but then we can write it now in the denominator with the exponent that's no longer negative, but what? But positive. Same thing with 6x to the power negative 2. That becomes 6 over x squared. All right. Okay. Yeah. Now some people usually insist and they go on and they say 1 over 2 root x. So they return that exponential form that's rational back into square root form, or root form if you want, plus 6 over x squared. This is the final answer, guys. Okay. Yeah. And this is it. All right, guys, I've just shown this step where basically you are taking the half, you are putting it forward, and then you're saying x half minus 1. Some people go ahead and they basically, you know, from here they write this step, and from here they write that step. And if you do that, you don't get any marks. If you go straightly directly, say f prime x half x to the power negative half, because some people do it in the calculator, the actual working out, because they know they need to bring by the same to the power half, but then they just subtract 1. Okay, minus 6, the negative 1 comes down, becomes times negative 1, which gives us a positive 6. Then x to the power negative 2, negative 1 minus 1, which is negative 2. And then, yeah, you then write your answers. As positive exponents. We don't leave our answers in negative exponents. We write our answers as positive exponents. And then that leads us to paradise. Okay. I hope this example 2, guys, is really straightforward and you guys see you know how it is that we go about it. Now let's look at 1.2.3. Okay, remember guys that with these questions, you know, they also use different notation. So here these problems predominantly have f of x, and so we are having to use f prime x. Remember, there is those questions that have dx, d of dx, dy over dx, and we need to know how to handle the notation whenever dealing with scenarios that have those kinds of problems. So I'm gonna see maybe if I can't locate a similar problem though. Now what do we need to do here? We need to simplify here. You know, simplification is very much needed here for this situation. So I'm sure you guys can see we have 12x squared minus 11x minus 15. This is a trinomial and it can be factorized. And this here in the denominator is also this is a binomial, it can be factorized. Okay, and yeah, it's very important how we go about factorize. So whilst we are busy simplifying, we don't write f prime x yet, we still retain. So let's just write this. Let's go to the denominator. Here in the denominator, it's clear that x is the highest common factor. We write 3x minus 5. Now I have a feeling that this 3x minus 5 has to cancel with something here in the numerator. So when I factorize this, it's going 3x minus 1. Then we are going to write 3x, yeah, and this bracket is going to have that minus 5, you know, and I'm going to check, you know, after I'm done. Minus 5 times what will give you negative 15? It will be plus 3. I think this is how it goes. So let's just check quickly if we do get this back when we multiply this. What's 3x times 4x? Will give us 12x squared. Then 3x times 3 will give you 9x. Minus 5 times 4x gives you negative 20x. These like terms, when you add them together, you get negative 11x. So this does make sense here. Makes perfect sense. And the only reason why I could sense that 3x minus 5 is going to be one of my factors for when I factorize this bracket is because I could see that in the denominator, this 3x minus 5 will somehow have to be eliminated by something similar in the numerator if we factorize this to have that similar thing. So this is the way that we would have to factorize this trinomial. 3x minus 5 into 4x plus 3. And when you multiply it back, you do get this 12x squared minus 11x minus 15. Okay, so that's how we factorize an advanced trinomial, right? An advanced trinomial, as we call it. So that means we have that over 3x minus 5. Cancel that. What are we left with? We are left with 4x plus 3 over what? Over x. I'd say we're very close now to making sure that we have one term, we have separate terms. Okay, what then now can we do? We write 4x over x and write 3 over x. So this we call splitting. We split the fraction. Now you can always split a fraction if you have many terms in the numerator and just one in the denominator. Guys, this only works when there's one term in the denominator and you have many terms in the numerator. If you have 2, it means you can split it twice. If you had 3 terms that are separate, you could split it 3 times with the same denominator. Okay, and then what happens? This in actual fact not completely ready, because remember, if f of x is equal to 4 plus 3 over x, this here, remember, has to be written in such a way that that term is in exponential form. Now, do you guys know what we can do in order to get the expression to be in exponential form? Gary, what can we do? Corey, what can we do here? so that we get that function, that expression 3 over x into exponential form. What can we do? Okay, I'm gonna wait for the powerful hand to lead and let us know what can we do. Oh, we're gonna slide. What can we do in this situation? What can we do in this situation? Because this term is nearly one term that has a variable in the numerator, but currently it's in the denominator. We don't want to have that. So what do we do? Okay, do we remember what we did here? Do we remember what we did here specifically? Or what I was explaining here? Okay, do you still remember that? 1 over x to the power 1. Coefficient still stays. The x goes up into the numerator. It changes from positive to negative. Same thing here. Okay. So Miss Him has attempted there in the comment section. So hopefully we can see that, right? So initially, before we, right, remember we have 4 plus 3 over x, which is f of x. So then that means we're going to write 4 plus, good, 3x to the power negative 1. Yes. Okay. Very good, Samantha. 3x to the power negative 1. Because remember, the x goes up to the numerator, joins the 3. But then it is a variable with a negative exponent the minute it changes position from denominator to numerator. Now we are truly ready to do what? To differentiate. So we say f prime x. Derive the constant, it's 0. Derive this, it's 3 to the times negative 1, x to the power negative 1 minus 1. Okay. And then we get a 0. Plus times a minus 0 minus 3x negative 2, 0 minus 3x negative 2, and then obviously that 0, we don't need it anymore. Our final answer of f prime x is negative 3 over x squared, because remember, if it's x to the power negative 2, that can be written as negative 3. The x goes to the denominator. It has a positive 2 exponent. That's done and dusted. Homo, can you please return to the previous question? What's the previous question? Which previous one? This one. Square root of x minus 6 over x minus 1. Is that what you're asking? Okay. What do you want here specifically? Gomo M. I don't know what is it you wanted to point out there, but I'll wait for you in the comment section. Is there something that you wanted to spell out? Something specific? Something you wanted to point out? Okay, Homo's not saying anything. Going once, going twice. Sold. Okay. So nothing specific then. Oh, thank you. Oh, okay. So you saw what you needed to see and then you could. Okay guys, if you can just hang on a sec. I'm sorry for the darkness. Which crystal is this? So you're asking about when am I going to do Euclid? Specifically, what do you mean? Euclid. What Euclid? want a calculator. Yeah, I want to do a bit of differential calculus. Do you mean grade 12 trig, or do you mean, grade 12 Euclid, or do you mean, that's what I need to establish with you. All right. I was wanting to find some questions on differentiation that have to do with other alternative notation. All right. Guys, we need to ensure that we also understand this notation. Okay. If they give us this and they say derive, all right, I need to also help you understand this notation is notation that oftentimes falls under the cracks, and people like don't know how to deal with when the notation is as such. But I'm hoping that we don't have such a problem and we know exactly what we need to do. So dx, all right, as well as d of dx is very similar as to like the approach, that is. Okay. So if you are given dx, what you need to do is, if there's a need, all right, let me actually do this as well. Let's do this as well. So what you need to do here is that dx does not go anywhere until you are ready to differentiate. Okay, it's the same thing. Dx and d over dx, all right, are usually just attached to an expression. So you can see that they are attached. There's no equal sign here. It's dx and then the bracket, and then your expression is given there. So what you do is that as long as you are still simplifying, as long as you are simplifying and have not yet derived, okay, as long as you are simplifying, then you must keep dx. So here, for instance, we need to first simplify this first, because we don't have separate terms. Remember, we only derive when we have separate terms. So, and they have to be in the numerator and in exponential form. So 6x squared over 3, for instance, we're going to write minus 3x over 3. But dx is still there because we have not, as of yet, arrived at a place where we can say we can derive. Then 6x squared over 3x will give us 2x squared. 3x over 3 will give us x. Okay. So again, dx is not going anywhere. Now we do have two separate terms, and we are ready to do what? To derive. So that means that dx now can fall away, and when it does, we go ahead and we derive. So our final answer is 4x minus x to the power 0, which is 4x minus 1. Okay, so the dx fell away when we derive. Okay, dx falls away, and that's very important. So yeah, and it's so that some learners, they don't make this fall away, and they keep it all the way, and that's where notation errors that basically will lead to marks being taken away from us. So dx operates in that same way, as well as d of dx. It operates in the same way. Okay, as long as you are simplifying, you must keep d of dx, but the minute you are ready, d of dx must fall away. So the question is, are we ready to derive? Yes, we are, because it's two separate terms. Variables are in the numerator, and the variables have an positive x. Well, actually, they are in the numerator with their exponents if they have any. So we are ready to derive. When we are ready to derive, derivative of 5, that's 0. Then 3x, that's 1 minus 1. So that means we have negative 3x to the power of 0 which is negative 3, because negative 3 times the 1, x to the power 0 is 1, so negative 3 times 1 gives us 3. You see, d over dx fell away the moment I derived, because I can see that they are separate terms. So dx and d over dx, they operate in that way. Okay, and then sometimes they do ask this in the following way: if y is equal to now this here, the derivative of y with respect to x. The derivative of y with respect to x. So that means it is the variable x that I need to be simplifying. Okay, yeah. Now sometimes, guys, there's a trick. Sometimes they will give you a question like this. They will say, if y into x minus 3 is equal to x cubed minus 27, find dy over dx. You see, so in this situation you would have had to first make y the subject of the formula. And reason why you are going to make y the subject of the formula is because we are being asked to derive this function but with respect to x, which means in the main body we have to have x. It can't be any other way, because we have to derive with respect to x. In the function of y, we need to derive with respect to x. Okay, so if you think about it, if the equation was given to us like this, it's a matter of isolating the y. So what we do is we divide by x minus 3 both sides. When we do that, the x minus 3 will cancel that x minus 3, and then we are left with y is equal to x cubed minus 27 over x minus 3. But this here needs to be further simplified into what? Into separate terms. Why do we need to have separate terms? Because remember, our condition for deriving means we need to have separate terms. All terms must be in the numerator and they must be in exponential form. Then we can use the power rule so that we can derive. So let's come back here. What happens with y is equal to x cubed minus 27 over x minus 3. I'm still going to keep this y and simplify it first, then we'll derive. So x cubed minus 27, that is actually, we can factorize x cubed minus 27. How? The first bracket will be x minus 3. How did I get this x minus 3? I simply took the cube root of x cubed, which is x, so there it is. Then I took the cube root of 27, which is 3, and then I put that x here, that 3 there, and then the minus sign that was originally in the expression there. Guys, this is factorization of a cubic expression as done in grade 10. Then what I do is I open a trinomial bracket. X times what gives me x cubed? It is x squared. Then negative 3 times what gives me negative 27? It is plus 9. And then in order to get this middle term, I know it will be positive. I multiply the x and the 3, not taking into consideration the sign because that's not important. So I write positive 3x. And you'll find that if you were to multiply this out completely, you will get x cubed minus 27 alone. All right. Now, this is all over x minus 3. Now, do you see where the cancellation happens? This guy and this guy, they go. So y is equal to who? X squared, plus 3x plus 9. I would say we are ready to do what? To derive. So when you are ready to derive, especially guys when it's dy over dx, this here is a special notation for derivation. You take your equation that you had, You simplify it. When you are ready to simplify, then you can say dy over dx is equal to, then you apply the power rule for each term. So that becomes 2x, that becomes 3, that's 0. So this is the answer. See, now I have jumped straight to the point. I've not done the long, elaborate 2 times 1x to the power 2 minus 1. I didn't do that. I went straight to the answer. Straight to the answer. All right, and that's no problem to do that, to go straight, because all of this, for me, to get 2x has happened in my head. To get 3 has happened in my head. To get 0 for 9 is happened in my head. So then that concludes that particular segment of the calculus. So guys, please, man, notation wise, you see dx. Notation wise, do you see d over dx? So with dx, you keep your expression until you have simplified it. When you are ready, then the dx falls away and derivation happens. You apply the derivative, and then you get your answer. Same thing with d over dx. You first, if simplification is needed, you simplify, but in this case you can see that the expression is already as simplistic with separate terms all in the numerator. The variable as well, all right, is in exponential form. So you can derive immediately. The d over dx falls away, you just write equal, and then you derive, you get -3. But remember, for this one, I said, for dy over dx, you are given an equation. You have to ensure that you simplify it first by factorizing, okay, as you can see here, and then cancellation, so that you can derive by introducing dy over dx, and then you derive each individual term so that you can get 2x plus 3, as you see me did here. Because remember, when you're deriving with the x squared, you take the 2 forward, 2 times the 1 that was there, x to the power 2 minus 1, so that gives you 2x. Then same thing here, 3x to the power 1 minus 1, that gives you 3 times 1, which gives you 3. Okay, so there is our salvation when it comes to these types of questions. Okay, now moving right along, I think, guys, we've touched on some important things when it comes to marks. A question related to calculus. Guys, you all need to know how to determine, and find the derivative of a function using first principles. Please, guys, very important. You guys need to, because look, this is 5 marks, okay, and deriving using first principle is a level 1 type question. So it is the freebie marks that everybody should get. Look at this one. Determining the gradient of a tangent of a particular function at a point. Don't forget that the derivative of a specific function at a point is equal to the gradient. Okay, if you know the specific point, you can substitute that specific point of x, the value of x, in the derivative, and then get the gradient for that particular function at that point for the tangent. 1.2, determine f prime x for each of the following. Remember, like I said, very important that in order for you to apply the power rule for deriving, you need to have separate terms. All terms must be in the numerator. You must ensure that they are in exponential form. So the art of converting our terms to exponential form, very, very important here. Okay, now I'm going to come over to cubic functions, because remember, I will cubic functions. Okay, so we have cubic functions. All right, I think, guys, today I'm not gonna sleep late, 12:30. Unfortunately, I'm not gonna stay on long because church is calling me tomorrow. Well, actually, it's already midnight. I can't afford to be half there because I was on a live for too long. So let's look at cubic functions, just a bit on cubic functions. f of x is equal to x cubed minus 3x squared plus 4 is equal to x plus 1 into x minus 2, the whole thing squared. So what's nice here is that the function of f of x is also given in root form. Okay, and I think if we were to actually check out this root form, we have x plus 1, we have x minus 2, but the x minus 2 is what? Is squared. So that suggests a few things, and that is, it would say to us first and foremost that x minus 2 is, there's only, x minus 2 is repeated, which would mean that one of our x-intercepts is also the turning point. Okay, it shares the x-intercept and the turning point, and that's when x is equal to positive 2. That specific point is the y-intercept. It is the x-intercept. It is also the part where the function turns. Okay. Also, what's also significant to note is that our value of a, the coefficient of x cubed, is positive. Now, for our shape of the function, that suggests that, remember, when a is positive, so I usually say you will be sad at the beginning, you'll be happy at the end. Okay? That's when a is positive. If a is positive, okay, the coefficient of x cubed is a is greater than 0, it means we are happy at the end. All right. You know how they say in these, they all lived happily ever after. Okay, I think that was accepted by mistake. Sorry, that was a mistake, a big one. That guy is going to feature in my live. Sweet stuff, isn't it? A white man. All right, so write down, so the question here is write down the y-intercept of f. They are not saying we must calculating it, they are saying write it down. So do we know what the y-intercept of f is? Can someone tell me in the comment section from what you see? What is the y-intercept? We are given the function in this form, but also in the x-intercept or root form, if you want to call it that way. So what is the y-intercept of f? Rutendo! Oh wow, Rutendo's joined the live. Hello, Rutendo. 4. Yes, guys. Yes. Okay. You can say y is equal to 4. I know some people say y int is equal to 4. Okay. They didn't say write down the coordinates of the y-intercept, but they said write down the y-intercept. So please, guys, don't just write the number 4. Y is equal to 4. You can say that. Or you can say y int is equal to 4. That's what we wrote down. Where did we get it? We simply looked by inspection at our form of the cubic function, and then we saw our constant is 4. So that means the y-intercept is 4. Had said write down the coordinates of the y-intercept, what would you have written down, guys? Written down, if I may ask. Write down the coordinates of the y-intercept. How would you have written that down? Let us see if people see the difference. What would you have written down if I said around the coordinates of the y-intercept? Sorry, guys, my Twitter messaging, what comments is probably the one that's limiting us from seeing people's comments. Let me try and approve comments first. Yes. Okay. If they say right down the y-intercept, very careful. Okay. So Rotendo, be careful with your writing there. Remember, this is the y value. Whenever you write coordinates, you write your x value first, you follow it with your y value. So Rotendo, when you said your y-intercept is 4, that means the y value is 4 when you let x be equal to 0. So that means your coordinates are 0 and 4, not 4 and 0. So let's just be slightly careful, and please guys make sure you write the brackets around the coordinates because that's how we represent points on a Cartesian plane. Okay. 2.1.2, determine the coordinate of the stationary points of F. 4 marks, and it's a level of the question. So that means, yeah. Means complex. So how would we determine the coordinates of the stationary points? What do we do, guys, when we determine the coordinates of the stationary points? Determine the coordinate of the stationary points of F. Written as like 2 and 0. Okay, remember when they say determine, it means we actually need to do some calculations, because determine means 4 marks, which means there must be steps that lead us there. Okay, so hopefully we all know that if we want to determine the coordinates of the stationary point, this derivative of the function x cubed is going to be 3x squared minus 6x plus 4 is 0 is equal to 0. Then that means 3x, highest common factor, left with x minus 2, then is equal to 0. Can you see question 1? The question 1 algebra is being applied in this situation. So x is equal to 0 because we divide both sides, or x is equal to 2. So return those answers there, you can see them coming. So since they wanted the coordinates, it means we are going to take these x values and then we function. We take the f of 0 of who? Of 0. And then we substitute in the place of x. And then get f of 0, which is 4. So that means the first point is 0 and 4. That's of the stationary point. Then we substitute f of 2 as well. And we get 2 to the power 2 is 4, minus 4 times minus 3 is negative 4. But of course, minus 12 is 0, so that means 2 is 0. So the other pair is when x is 2, y is 0. So we have 0 and 4 and 2 and 0. Those are the coordinates. Point. We have 0 and 4, and we have 2 and 0. This is very interesting, don't you think, guys? That the y-intercept is actually also the turning point, and that one of the x-intercept is also the what? The turning point. Isn't that very, very interesting? Now in 2.1.3 there's sketch the graph of who? Of f. Guys, what do we need in order to sketch the graph of f? We need to establish shape, because it's nice with the end in mind. We need to establish the shape. Where do we get the shape of the function from? We look at the coefficient of x cubed. It is 1, which means that we are smiling at the end. We are sad at the beginning, smiling at the end, sad at the beginning, smiling at the end. I say we are positive, right? And hopefully all of us will be positive with our final end of year exams. We'll be positively happy as we write our final end of year paper as well. Okay, so that's where I usually start. I start at the shape. I look at the coefficient, especially given the function, the whole entire function. Then you can start there at the shape, and in your head you can establish, okay, what shape am I expecting my function to be like? So I know I'm beginning with the end in mind. All right, it's very important to begin with the end in mind. It's like, for instance, as you are preparing for your final end of year exams, you are preparing with a very sharp, clear picture in your head of the end you want to attain. And the amount of work you are putting in is indicative of the outcome you want at the end. So if you want a level 7 that's 90 and above, that means the kind of work or preparation that you will be participating in will be quite rigorous. It will require a lot of sacrifice, because what are you doing? What you are doing now is fueled by the outcome you'd like to achieve at the end. So that's very important to always have in mind. So that's why I say, if you know the shape, then at least you have an idea. Secondly, Rutendo speaks about x-intercepts. So what's beautiful here for this function is that we are given the factor form of the function, x plus 1 into x minus 2, the whole thing squared. So in other words, this is like us saying x plus 1 into x minus 2 into x minus 2 is actually, when we want the y-intercept, when we want the x-intercept, we let y be equal to 0. So that means f of x is 0 in light of that. So that means we have x is equal to -1 or x is equal to 2. So our coordinates of the x-intercept are actually -1 and 0, 2 and 0. So we have the x-intercepts. The y-intercept, we also have it, Moss. The y-intercept is 0 and 4, so we are fine with the y-intercept. The stationary points as well, we have 2 and 0, we have 0 and 4. There's one last thing that I would like to have. I call it the POI. Do you know, guys, what the POI is? All right, I tend to want to have that POI also in place so that I can know where my POI is. Do you guys have an idea of what I'm talking about here? I know POI means various things in functions, but specifically for the cubic function, Mrs. Sim, you remember when I said POI means many things in functions? Yes, POI does mean point of intersection, but I'm guessing with the word that I was really looking for is the one that Rutendo has just mentioned, okay? And maybe what I can then do is, so that I can avoid confusion, let's say the POINF, so that people can differentiate between POI for point of intersection, because I understand why you would say that, Miss Him. Specifically, I was referring to the point of inflection. In other words, what is the point of inflection? It's where the graph changes concavity. Okay, yeah, it changes concavity, and for this one it would be smack bang there. It's like sort of like midway between the x values of the stationary point. It's like midway, it's like the midpoint. Point of inflection is the midpoint of the stationary points. That's where it is. And in actual fact, whenever we want to get it, we actually have to find the second derivative, having equated it to 0. That's how we find the point of inflection. So I'm just gonna reveal the point of inflection. So I remember that I did derive the first time, so let's derive this the second time. That means we get 6x minus 6. And if we solve for x, we get x is equal to 1. All right. And if we want to get the corresponding y value for the point of inflection, we take the x and we substitute it into the original function. So I just say f of 1 is equal to 1 cubed minus 3 into 1 squared plus 4. So what I do get eventually is 1 minus 3 plus 4. 4 plus 1 is 5. 5 minus 3 is 2. So f of 1 is 2. So that means I have 1 and 2 as my point of inflection. I have everything that I now need to sketch my graph. So let me go now. You see, what I love this is that I've been provided I've been provided the graph paper to sketch, the graph paper to sketch, the graph paper to sketch, the graph paper to sketch. All right, which is so sweet. So let us sketch ahead then. So x-intercepts, let's first make a mark of the x-intercept. What did we say the x-intercepts are? -1 and 0, you are here, that's where you are. 2 and 0, you are here, that's where you are. Then was it? Okay. Okay, yeah. Then stationary point, x is equal to 0. All right. There's one. And where's the other one? Stationary point, the other one. 2 and 0, obviously we are coinciding the same place there. What else? Point of inflection, when x is 1, y is 2. So when x is 1 is here, y is 2 is there. Where do they meet? So x is 1 is everywhere on this vertical line, y is 2 is everywhere on this horizontal line. Where do they meet? Exactly there. Okay. Hey, I hope we're seeing this, guys. Oh, but they want to cuss later. Yeah. Okay. Seems like cuss later is coming in nicely, hey? All right. So let's go. Let's connect. So in my head, look, I already have an idea of the shape that I want. Okay. So this x-intercept, I'm seeing it go there. We turn there. We come here. We turn there. You see? It's coming nice, it's coming nice. Right, so let's go. Let's go. There we have it. Isn't this beautiful? Isn't she lovely? Ooh. Isn't she wonderful? Oh yeah, she is. I think she is beautiful. She's beautiful. Never thought. F of x is so beautiful, like, so beautiful. Let's mark the point of inflection 1 and 2. 0 and 4 is there, so the 4 is fine. -1, clearly defined, I can see it. 2 and 0 as well, clearly defined, I can see it, you see, because there's the 2 already there. Okay, point of inflection I can mark, that's fine, as like the actual definitive points, but everything else I can see very well. All right, -1's there, the 4, the 0 and 4 there, and then the 2 and 0 there. Okay, then I can label the function at least and say f of x is equal to x cubed minus 3x squared plus 4, so that they know that I sketched that function. It is what it is. Is there anything that's missing, guys? I think that's it. That's the graph. All right. Yeah, so we need to know at least how to sketch a basic graph. Now, I understand that, more fully in exams nowadays, they're becoming a bit more creative around sketching of functions. And I think what I'm going to do in a subsequent live session that I do with the grade 12s, I will expose you guys to the other alternative ways in which how to sketch a function can be asked. Because sometimes it's not as clear, straightforward as when they give you the function like this. Okay, and then you find x-intercept, y-intercept, turning point, stationary point. Sometimes they give you a list of information and they need to sketch the graph based on that list of information. That's how exam type questions nowadays are being asked. So I will expose you to those, but just not today, unfortunately, because I do have limited time. So next time, let's come here. For which value of x is f of x less than 0? Now, I was answering questions like this in the live session with the grade 10s when they were looking at when they were looking at trigonometric functions. Now, the same type of question is being asked, and we are looking at a cubic function. What does this question mean? So this question means they want you to tell us the value of x, all right? They want you to identify, in actual fact, the interval, you know. So from left to right, they want you to show the value of x where f, what is f? F is this cubic function that we've just sketched. We need to show where this cubic function, right, is less than 0. Now, where f of x is less than 0. What does less than 0 mean? Less than means below. Below. Ngaphansi. Ezansi. I don't know how to say it in any other language. But here, below, underneath. Where is the function underneath? Underneath what? Now, this 0 represents y is equal to 0. In other words, where is this function below the line y is equal to 0? Now, the line y is equal to 0, guys, is simply the x-axis. So that's why we say we're asking in actual sense, where is this function below the x-axis? So we come here. Where is the function below the x-axis? So we have to then move from left to right and check where is the function. Which x values show us the function being below the x-axis? So guys, you can see that this function everywhere before -1, you see, this function will continue infinitely to be below the x-axis. Before -1, meaning less than -1, where x is less than -1, the function is below the x-axis because you see it below. But at -1, it's equal to it's on the x-axis. So there's no answer at -1. There's an answer before -1. In other words, where x is less than -1. So you can say x is less than -1. You could write your answer that way. Or, as I think Runtendo was meaning to say, and I think she actually corrected herself in the subsequent comment, where x is an element of, open brackets, negative infinity. Guys, remember, negative infinity to where? To -1, and then you use your open brackets, because we are not looking for when it is on the x-axis. We are looking for when it is below the x-axis, which means we don't include -1. So that's why we use open brackets. And infinity, of course, negative infinity and infinity are never included because those are not fixed numbers. I mean, sorry, it's not a number, infinity, or negative infinity. It's a representation of numbers that go on forever in the negative direction. So negative infinity to -1 would be an alternative way of writing the same answer. Which one do you guys prefer? Do you prefer option 1 or option 2 in writing your answer? Do you guys prefer writing your answer this way or that way? Which one do you guys most prefer to write your answers? Okay, all right, I see Nintendo. So Nintendo loves the x is an element. Option 1 for Mrs. Him. Okay, well guys, as long as we are doing the right thing, okay? As long as we're doing the right thing. Now, the next question. What is the next question asking? I see Akan. What is the next question asking? It says f prime x, and then it says less than 0. What is this speaking to directly? Does anyone know? Anyone know? Anyone who's anyone? What do they mean when they say f prime x less than 0? Okay, Runtendo says a happy face or sad face. But I need to understand specifically. Okay, Runtendo says the shape of the graph. What does everybody else have to say? Runtendo, I've heard you. What does f prime x less than 0 mean? What does it specifically have reference to when we say f prime x less than 0? Okay, Runtendo says point of inflection. Okay, so Runtendo, you've said a lot of things. You said happy face or sad face. Then you said the shape of the graph. Then you said point of inflection. Okay, and I think I see what you mean, but I need to get an indication. What does everybody else think? Is Runtendo even telling us the truth, or is Runtendo having a slight misconception which just needs to be corrected? That's my question to the rest of the people that are tuning in, because this question, guys, is a popular question. So they say this question, f of x is less than 0, these questions are level 1 questions, quite straightforward, knowledge based. It's really knowledge based questions. But here, f prime x less than 0, this is a level 2 question, so it's slightly more complex, but really there's nothing to it. Okay, so what do we mean by f prime x less than 0? Okay, so I'm going to explain what it means. If we say f prime x, guys, less than 0, all right, this refers to where our function is decreasing. Okay, decreasing. In other words, where the gradient is negative. Okay, please, guys, this is very important. You are looking for where the gradient is negative, where the function is decreasing. And when you look at it, you have to ask yourself, here, what's happening? Okay, and obviously on this side of the graph, if you were to put any straight line, any tangent along this line, what kind of gradient or what kind of straight line would you have? Okay, if you put it, if you mark a point there and you draw your straight line, what type of line is it? You mark a point there, you draw, what kind of line is it? Is it a decreasing straight line or increasing straight line if you put it on this side? It's obviously a increasing straight line. In other words, it's a positive gradient straight line. So that's where f prime is actually greater than 0. We wouldn't say f prime is less than 0 on this side. Okay, the way to the turning point, this is a positive gradient. In other words, this is where f prime is greater than 0, right? So that means from where x is equal to 0, where x is less than 0, we have a positive gradient, or in other words, an increasing function. So therefore, we have an increasing gradient. So that means we do not, we could have increasing straight line functions along this particular side of the function. So that means f prime x is greater than 0 here. Okay, let's come here. What's happening this side? Okay, from x is equal to 0 to 2, what's happening here? We have a decreasing, all right? In other words, our gradient here is what? It is negative here. Okay, gradient of the straight line, any tangent we'd place here would have a negative gradient. In other words, f prime x is less than 0, all right? Where from x is equal to 0 to x is equal to 2. Okay, very, very important what I'm saying here. Then what's happening here from 2 to infinity? Here we have a increasing function. In other words, we have a positive gradient. Okay, so in other words, what that means is that this is where we would have a what? This is where we would have a positive. F prime x would be greater than 0 here. All right. So if you now reflect on all of what I've said, guys, this is what I mean by F prime. But what Rontendo was meaning to say earlier on, I think Rontendo was speaking specifically about what? You were speaking, Rontendo, about F double prime, where you talk about the concavity, all right, the shape of the graph. Okay, so for instance, if you say F double prime is greater than 0, then you are saying positive, which means you mean concave up. Okay, but if you say F double prime less than 0, then you mean concave down. Okay, so I think you were referring to that specifically. This is concave up, concave down. So you're looking at your graph and you are checking, okay, that exactly. If you are doing the second derivative greater than 0, second derivative greater than 0, concave up, second derivative less than 0, concave down. So just the question then comes back to this. For which values of x is f prime x less than 0? Right, so hopefully we can see where f prime x is less than 0. F prime x is less than 0, where exactly? It's from 0 to 2, because that's where we are decreasing, from 0 to 2. So we can say x is an element of 0 open brackets to 2. Done. Okay. Yeah. Okay, I think we can end it right there for today, guys. I will definitely continue with this, all right, calculus, and we will also dive deep into other types of questions. So you will see me going back and forth, unraveling other questions that have to do with first principles that are slightly different from this, but which need us to actually go a different route when we are simplifying. So I'll look at some of the others, tangent type questions that are of another nature, different notation questions apart from f of x that are of another nature. We will look at other cubic function type questions where we don't have the roots given to us. How do we find the roots if we are not given an expression where it is factorized for us? How do we go about that? Then of course we'll look at other questions as well where we are given points and we have to sketch a function from those points, and we will also look at other interpretation type questions so that we can become well versed and are fluent in those questions as well. Okay, so hopefully this live lesson was very helpful. I really want to thank those of you that joined in. I know it's, like I said, it's like literally wee hours of the morning. It is 12:46, so I commend you guys for being here and for just joining in the session. Thanks for the follows, those that followed the live creator. Nintendo, thank you so much as well. I'm glad that the session was helpful for you. Mrs. Him, thank you again most heartily to you for the surprise confetti there. I really appreciate that gift. Very much appreciated. You know, these kinds of gifts, they are very rare in my life, so I really appreciate. God bless your heart. May he add to where you have taken that much more, and also more importantly fulfill the deepest desires of your heart, especially as they pertain to your academics and also just your maths performance. Thank you for joining. And thank you, Samantha, for joining. I know you said you joined a bit late, but it was good having you. Mr. Just Now, you were here. Thank you so much. Zenande, I didn't see you there. Okay, you were here as well. Good to have you. Ukaili, Browns, Sia, Lesedi Katlejo, Savage, Fez, True Love Babe, Atengos Zen, Tandoju, Luke, Samambondo, Nhlanhla, Nicole, Nokwazi, Cornele, and Petojo. It was good having you guys. All these other topics will come in due time. Mr. Just Now, what you are probably not realizing is that we are actually taking a slice of a piece and a piece at a time. So those that have been here in previous live lessons will know that we started out with your question 1 based questions. We slowly but surely went on from one aspect to another. So we've been moving from one aspect to another. We came from functions as well, and we were doing that. So all these live lessons that I've done, the actual live recordings on my YouTube channel. You can check those out. The YouTube link is in my bio, and it's grade 12. You can see it from the thumbnail. The thumbnail of each video is written just on the outside with the grade 12 paper 1 trial exam preparation. You'll see the videos, they are written as such on the thumbnails. And yeah, you can check out what we've done previously. Videos are quite long, of course, because it's the live lessons, the lengthy long live lessons as you see them, with a lot of rambling in between, as you hear me ramble right now. So yeah, so we'll do other topics, Trig we will definitely do. Trig is fun. We'll do Euclidean, we'll do probability, we'll do statistics, we will do analytical geometry. So all of these topics, they will definitely do them. We'll tackle them and we'll show them who's boss. Thank you so much for joining, and have a great night, guys. Loads and loads and loads and loads and mega much love to all of you. Cheerio. Bye. Short and Cheers.